Saturn. Saturn, with its beautiful yellow glow, is distinguished from the solar system's planets by its magnificent rings around its equator. Saturn is the second largest planet in the solar system with a large family of moons. The planet has been under scrutiny since 2004 when the Cassini spacecraft entered orbit. Named after one of the Roman deities and Jupiter's father, Saturn, it is the sixth planet in the solar system. The planet is about twice as far from the Sun as Jupiter is from the Sun. At a distance of Saturn from the Sun's brightness is only about 1% of what is felt on Earth. It takes only 10.5 hours for Saturn to orbit itself. The planet's axis of rotation is curved 26.7 degrees relative to its equatorial plane, which means that each time the planet orbits the Sun, its poles bend toward the Sun several times. This deviation of the axis, along with the weak radiation of the Sun and the internal heat source of the planet, has caused seasonal differences on the planet. When we look at Saturn, we see the top of the planet's atmosphere, mostly composed of hydrogen and a little helium. This visible layer creates thin, faint belts parallel to the planet's equator. Saturn is about 9.5 times wider than Earth and 9.5 times farther from the Sun. Saturn has 95 times the mass of our Earth, and 764 Earths can be placed inside Saturn. Saturn is mainly made of hydrogen and helium, the lightest elements. Under this gaseous atmosphere, these materials are compressed together, liquefied, and formed into metallic liquid. Although the planet's atmosphere is composed mainly of hydrogen and helium, there are small amounts of other gaseous substances inside the planet that have formed black clouds in the planet's atmosphere. If you have a huge ocean of water, you will see Saturn floating on it. The planet's rapid rotation around itself causes its material to be ejected, making Saturn the steepest planet in the solar system. Atmosphere Saturn. In the highest layers of the atmosphere of the planet Saturn, a cover of fog has given the planet a calm and firm face. But there are hurricanes and huge electrical storms in the area. At the same time, the collision of solar winds with the atmosphere creates a stunning view of the Aurora borealis. The planet Saturn's rapid rotation and the internal thermal currents that rise from the lower layers of the atmosphere create rebellious and strong winds in the atmosphere. The gases that make up the upper atmosphere form parallel bands that orbit the planet, and it is inside these bands that clouds and storms form. Storms in the upper atmosphere may be seen as bright clouds with the naked eye. But those that are hidden from view are detected by radar radiation. An area below 30 degrees south latitude, known as the Hurricane Passage, has seen 9 major storms since 2004. One of them, known as the Dragon Hurricane, emitted intermittent radiation from powerful radio waves for several weeks. Scientists think that the speed of these storms, like what happens on Earth, is a factor in generating electricity. However, this is happening on a much larger scale than on Earth. A hurricane in Saturn's atmosphere lasted for 7.5 months in 2008, causing lightning up to 10,000 times stronger than Earth's. Saturn's atmospheric bands surrounding the planet spiral the planet's poles, and each polar region is surrounded by a vortex-like storm. This vortex has a hexagonal structure around the North Pole. The hexagonal vortex, first discovered by Voyager, was still there until 20 years later when the Cassini spacecraft reached Saturn's orbit. This vortex structure, a nest of hexagonal bands centered on the planet's pole, results from the region emptying clouds up to 75 kilometers above Saturn's atmosphere. Images taken from the area over 12 days in 2006 show that the complication is locked in the pole and does not change position. The vortex around Saturn's south pole looks like a large eye. Its center is about 1,500 kilometers in diameter and is a cloud-free area surrounded by large walls of clouds. The wind is blowing around this ring at a speed of 550 kilometers per hour. Cassini continued to observe these polar vortices during different seasons of Saturn. The spacecraft examined the effects of rising sunlight on the northern vortex and investigated the role that the planet's internal heat plays in making these massive polar storms stronger. Aurora. Stunning views of colorful lights and dancing, known as Aurora Borealis, are a familiar sight in the Earth's polar sky. Similar views of this landscape have been observed over both poles of Saturn. Auroras occur when particles from the solar wind collide with gases in the upper atmosphere, and as a result of the action between them, radiations of energy are released in the form of light rays and radio waves. These lights are mainly the result of this reaction with oxygen and nitrogen gases on our planet. On Saturn, these lights continue to an altitude of 1,600 kilometers above the clouds, resulting from the response of solar winds with hydrogen gases. Saturn's auroras last from a few hours to several days, appearing mainly at ultraviolet or infrared radiation wavelengths. But on Earth, these lights last for a few minutes and are most visible in the light. Saturn's rings. Saturn's rings are the largest, most complex, and most spectacular ring system among the four giants of the solar system. These rings were first observed 400 years ago and were considered solid stone rings. We now know that each of these rings comprises millions of particles, and the ring system is much larger than we thought until a few years ago. The ring system consists of many single rings and gaps between them. 7 rings are named after the letters of the English alphabet, and the order of these letters is in the order of their discovery. The width and depth of each ring are different. Among these rings, ring B is the widest and is about 10 meters deep. Each ring is made up of dusty water ice particles ranging in size from a small dust particle to 1 meter wide boulders. Ring D is the closest ring to the planet. Still, the rings that are easier to see than the others are the 3 main rings, A, B, and C. Behind them are rings G and F and a dimmer ring, E. In 2009, a giant ring and donut-shaped figure were discovered far beyond Saturn and its ring system. The Spitzer Space Telescope detected infrared radiation from colder ring dust. The ring remained unknown all this time, as the scattered distribution of its constituent particles made it virtually impossible to see. Rings are an active and changing system. The moons that orbit the system interact with it, directing particles into rings and maintaining distances between them. The small moon Prometheus is likely to deform the F-ring and adjust the ring's inner edge, while the Pandora moon, which is beyond the ring and orbits the planet, shapes and adjusts its outer edge. Cassini on Saturn. One of the largest and most complex spacecraft to explore the solar system was launched into orbit around Saturn on July 1, 2004. Cassini began his mission on this date to explore all the elements of Saturn's system, which included Saturn itself, its rings, and moons. The spacecraft is almost cylindrical, and its scientific instruments are installed around its main body. On one side was the Huygens probe, and on top was an antenna to communicate with the ground. The radio signals from this antenna took about an hour and a half to reach the ground. At launch, the Cassini-Huygens spacecraft consisted of two parts: Cassini round orbit and Huygens probe. When the spacecraft landed on Saturn, Huygens left to land on the surface of Saturn's largest moon, Titan, to study its atmosphere and surface. Cassini was the first spacecraft to enter orbit around Saturn and had a long and detailed study of Saturn's system on the agenda. The spacecraft adjusted its position so that its 12 scientific instruments could study the planet, its rings, and its moons. The position of Earth and Saturn determined the Cassini-Huygens launch date. Since the spacecraft was too heavy to send directly to Saturn, it was sent from a path to Saturn to use the gravitational force of the planets Earth, Venus, and Jupiter. As the spacecraft approached Saturn in 2004, it passed one of the planet's moons, Phoebe. After this, a route correction maneuver took place, and a month later, the spacecraft reached Saturn. The spacecraft approached Saturn from the bottom of the ring and passed through the gap between rings G and F. The main engine slowed the spacecraft fast enough for Saturn's gravity to trap it and send it into orbit so that Cassini-Huygens could begin exploring Saturn's system. The Cassini-Huygens spacecraft traveled twice to Venus and once to Earth and Jupiter, once en route to Saturn. Each time this happened, a small amount of the planet's orbital momentum was transmitted to the spacecraft, causing it to jump in speed. Cassini-Huygens also passed close to Titan. During his second bypass in December 2004, he maneuvered to enter a position suitable for the release of Huygens. From then until the end of the Cassini mission, the spacecraft performed several gravitational maneuvers alongside Titan, using the moon's gravity to change direction or velocity. A change in the angle of Cassini's orbit around Saturn means that the flight path can move it farther away from the plane of Saturn's rings so that the spacecraft can get a view of Saturn and its rings and moons. On December 25, 2004, Huygens detached himself from Cassini deck and made his way to Titan. 20 days later, as the atmospheric shield slowed Huygens' speed and protected the valuable payload of the landing module and its tools to a height of 160 kilometers, a series of events and pre-scheduled landing instructions started themselves. 2 membrane layers were ejected, and the parachute reduced the probe speed to a safe level. Huygens finally landed on Titan's surface on January 14, 2005. Cassini was originally scheduled to study Saturn for 4 years, but its mission was extended until 2017. By 2017, Cassini had orbited Saturn more than 290 times and more than 110 orbits around Titan. On September 15, 2017, the Cassini spacecraft completed its mission and landed on Saturn to prevent pollution of the subsurface oceans of Enceladus and Titan. Saturn moons. Saturn has at least 82 moons around it. These moons are very different in size and distance from the planet. Some have orbits between Saturn's rings, and others are far from the planet. They are all named after the myths of different cultures. The massive size of Titan, which is similar in size to Mercury, made it the first moon of Saturn to be discovered in 1655. During the 30 years after this discovery, the next 4 large moons of Saturn were discovered, each with a diameter of between 1,000 and 1,500 kilometers. Saturn has 7 major moons. The rest of the moons are small, irregular objects made up of ice and rock, classified into two main groups: inner and outer moons. Saturn's large moons are larger than other moons on the planet. From largest to smallest, these moons are Titan, Rhea, Iapetus, Tethis, Enceladus, and Mimus. Mimus is the group's closest moon to the planet, orbiting the planet once every 22.6 hours. Only Titan and Iapetus are outside the rings. Titan is 1.2 million kilometers away from Saturn and orbits the planet every 15.9 days. Iapetus is about 3 times farther from Saturn than Titan, and it takes 79 days to complete one orbit around Saturn. Iapetus, meanwhile, is the only moon of Saturn's large moons in orbit that is dramatically angled from the planet's equatorial plane. All the large moons are locked in their orbit around the planet, and like the moon, they always show one side of their face to Saturn. Titan. Titan, which is slightly larger than Mercury, is the largest moon of Saturn and the second largest moon in the solar system. Titan is a cold world made up of ice and rock with a dense, impenetrable atmosphere. Discovered in 1655, Voyager first explored the moon. The world under the moon's atmosphere began to unfold only after the Cassini-Huygens spacecraft landed on Saturn in 2004. The mission involved repeated moon transits and sending the Huygens probe to the surface of Titan. The Huygens probe has revealed that a full gas shield envelopes the moon. 98% of this gas cover, several hundred kilometers high and 4 times the density of the Earth's atmosphere, is made up of nitrogen. A smoky yellow haze in the upper layer of Titan's atmosphere creates the moon's distinctive honey color. Although Titan is a large moon, its atmosphere is surprisingly dense. This moon has been able to hold such an atmosphere around it because Titan is an extremely cold world. The moon's surface temperature is about -178 degrees Celsius, and the cold gas molecules do not move fast enough to escape the moon's gravity trap. Titan's clouds formed and moved like clouds on Earth. But their speed is much slower. These clouds, made up of methane and ethane, are so dense that they can produce powerful but rare rainstorms. The presence of wind and rain causes surface and land-like features, such as rivers, waterways, and sand dunes. Due to nitrogen in the atmosphere and liquid on the surface of Titan, this moon is a sample and a colder version of the early Earth. The low sunlight that reaches Titan cannot pass through the dense and foggy atmosphere of the moon. As a result, the moon has become a dark world. Observations made by Cassini instruments as it passed by the moon and data returned by Huygens to Earth showed us the face of the moon's atmosphere. There are mountains, lakes, dunes, and ice and methane volcanoes. The small number of impact craters indicates that Titan's surface is geologically young. The moon consists of lakes of liquid hydrocarbons, including liquid methane and ethane. Enceladus. Enceladus, which orbits Saturn in a delicate earring, is 512 kilometers in diameter. This moon is one of the brightest objects in the solar system because the icy surface of its water reflects 90% of the light received from the sun. Enceladus is slightly larger than its neighbor, the moon Mimus, and was once thought to have a surface covered with impact craters, like Mimus. But Cassini's transits showed that parts of the moon's surface were continuously renewed. This moon is a geologically active world. Near the moon's south pole, 4 fissures spew ice particles, water vapor, and organic compounds from the surface. These eruptions create a temporary atmosphere for the Moon, feeding the E-ring and supplying it with the material. Mimus. Mimus is the innermost and smallest of Saturn's largest moons. The Moon's orbit is inside the ring system, emptying the middle region of rings A and B of material. This moon is composed of rock and ice water and has an average diameter of about 397 kilometers. Mimus is not completely spherical and has a longitudinal imbalance of about 30 kilometers. The Moon's surface, the temperature is minus 209 degrees Celsius, and impact craters scar its face. Herschel's giant crater makes the rest of the crater look dwarfed. This crater is the most significant surface complication of Mimus, which is 139 kilometers in diameter and 10 kilometers deep. The crater is named after William Herschel, the English astronomer who discovered the Moon in 1789. Tethis. Tethis, with a diameter of 1,072 kilometers, is the fifth largest moon of Saturn, orbiting in the structure of Saturn's rings. The full rotation of this moon around Saturn takes 45 hours. The largest crater of Tethys is called Odysseus, which is 445 kilometers in diameter. The edges and central apex of the crater have been destroyed, indicating that Tethys was in a semi-molten state when the collision occurred and the crater formed. Rhea. The second largest moon is Saturn Rhea. This moon is the first moon of Saturn, which is located beyond its ring system. This world is formed of ice and rock, has a diameter of 1,528 kilometers, and orbits Saturn once every 4.5 days. Impact craters mostly cover the Moon's surface, and there is no sign of a soft surface or surface area being regenerated, indicating that the Moon has an old geological surface. Cassini's passing by the Moon in 2005 hypothesized that the Moon had a delicate ring around it. Rhea would be the first known moon to have a system of rings around it if proven. Hyperion. This icy mass is the farthest from Saturn's inner moons to the planet, orbiting Saturn once every 21.3 days in outer orbit. Hyperion has a strange appearance. Its length is 370 kilometers, and it is one of the solar system's largest objects with an irregular appearance. The peculiar appearance of this moon is due to its low and unusual density. Hyperion is highly porous and has very little surface gravity. The collisions eject the surface material, and instead of returning to the surface, they escape the gravity trap and leave it.